Okay, there's always a process of pulling everything together, by the way, and it pays to be organized. The one thing I tell you is I have a lot of arctangents to deal with, all right? I want to point out, when I do this over here, we are, let me get my eraser out to get rid of all this nonsense over here. And I'm going to emphasize what we're adding together. And we're trying to do an integration of all these tiny pieces over here. So if you just did these things over here, and there's going to be 3 of those, you would need a common denominator of 6. So I'm going to say that looks fairly simple to do, and that's all I did over here. I put a 6 down and took those 3 things, pulled them together. The next thing I did was let me get my eraser out too. I took these 2 and I pulled them together. But when the constant together, it's going to be together just some constant in the end. So if you were to look at this over here, let me write this down for you. It's really root 3 over 12 times, I'm pulling this together, these 2 together. I know there's a constant there, by the way. And what are you going to get? You can get the natural log, x squared, plus root 3. You know what? There's supposed to be an x there, and I'll correct that, by the way. Root 3x plus 1 minus the natural log of x squared minus root 3x plus 1. And what do you get there? You get root 3 over 12 natural log x squared plus root 3x plus 1 over x squared minus root 3x plus 1. And that's how I got this thing over here. And that's right over there. So we pulled them all together. It was tough. It's a really tough problem, by the way. As you know, we're doing this in pieces. You're probably looking at just with prior knowledge about taking an hour to walk through that, all right? I would say more interesting problems do take more time, by the way. And if you're paying attention to this, good for you. Thank you.